Hello, this is Mrs. Youd, and today I'm going to teach you about graphing quadratics again. This time we will be using the intercept form. This is Chapter 8, Lesson 5 of the Big Ideas Math curriculum. Our first exploration is to use zeros to write the function. You'll notice that the instructions say each graph represents a function in either this form, f of x equals parentheses x minus p, parentheses x minus q, or this form, which is the same exact form as the first, except it has a negative out front. So my first thing to do is to find the zeros. I notice on letter A, my zeros are here and here. So my zeros are 1 and 2. Since this is a happy shaped graph, or it's opening up, we're going to use the first one, which is this one here. And so I just need to write my function, f of x equals x minus 1, x minus 2, because those are my zeros. On letter B, I also have the same zeros, 1 and 2, but this time it's opening down, which means I'm going to have this, I'm going to be using the second one here because it has the negative out front. So it will be f of x equals negative parentheses x minus 1 parentheses x minus 2. For letter C, my zeros are 0 and 3. So my answer is f of x equals x minus 0 and x minus 3. Now this one we don't need the 0 here, so I'm going to simplify it to say f of x equals x and x minus 3. That's a better way to write that one. You go ahead and try D, E, and F on your own, and then turn the video back on to see if you got it right. Okay, for letter D, I got x, and notice it says x plus 3 because my 0 is minus 3, so that's a double negative, which means it's positive there. On letter E, it's the same thing as letter D except for there's a negative out front because it's opening down. And on letter F, we have a negative as well, and it's x minus 3 since that's a positive 3 there. On letter G, we have a 0 of negative 1 and positive 2, so then it would be f of x equals x plus 1 and x minus 2. On letter H, we have also negative 1 and positive 2, but this time it's opening down, so we have f of x equals negative x plus 1 and x minus 2. Okay, so what are the characteristics of the graph f of x equals a, x minus p in parentheses, x minus q in parentheses? Those characteristics are, so the a tells you if it's going to be opening up or opening down. If it is a positive a, it's going to open up. If it is a negative a, it's going to open down. It also tells you if there's going to be a stretch or a shrink. We didn't have any of those in our examples, but it does tell you if it is going to be a stretch or a shrink. And then the P and Q tell you where the zeros are. And the zeros are where the graph crosses the x-axis. Okay, next question. Does changing the sign of A change the x-intercepts? And the answer for that is no. The x-intercepts do not change. The only thing that happens if A changes its sign is that it opens up or opens down. And the next question, does changing a sign of A change the y-intercept? And the answer to that would be yes, because the y-intercept will either be on the top, above the x-axis, or below the x-axis. Okay, next question. Does the changing the value of p change the x-intercepts, or does it change the y-intercepts? So it does change the x-intercept because it tells you what the 0 is, and the 0 is where it crosses the x-axis. However, it does not change the y-intercept because the value of p doesn't change whether it's vertically stretched or compressed. It just tells you where it crosses the x-axis. Okay, so our only vocabulary on the next page is intercept form, and an intercept form is actually written right down here. It is a and then x minus p in parentheses, x minus q in parentheses. You'll notice that the x-intercepts are p and q. The axis of symmetry has to be halfway between because it is, so if the x-intercepts are here and here, then the axis of symmetry is halfway in between, which means it's an average of the zeros. And that's what it says right here. It's you add together the p and the q and you divide by 2. The graph opens up when a is positive and the graph opens down when a is negative. So I'm going to insert a little extra example in here for you, if you could write this down. We're going to find a quadratic function in standard form whose graph passes through these 3 points. So the first thing I'm going to do is I'm going to use my intercept form that we just learned about. Because I can see that this is a 0 and this is a 0, that intercept form will be useful for me. And there's my intercept form. We know that -5 and +9 are the intercepts, so that's the first thing I'm going to do is I'm going to plug in the -5 and the 9 for my p and my q. The next thing I'm going to do is plug in the other the other point that I'm given into my x and my y. So I know that x is 8 and y is -39. Now all that remains is to solve for the letter a. And I got a is equal to 3. So now I just need to go back and find what my equation is. And I'm going to be using this equation up here, but instead of a, I will go ahead and plug in what a equals, which I got as 3. Okay, if the question asked for me to leave it in intercept form, I would be done here. But the question is asking me for me to write it in standard form, so that means that I need to continue multiplying this out until it's in standard form. And there I have my final answer. F of x equals 3x squared minus 12x minus 135. Okay, moving on to the next page, we're going to try some practice problems. In exercises 1 and 2, we're asked to find the x-intercepts and the axis of symmetry. So I'm going to start with my intercept form, a parentheses x minus p, x minus q. Remember that p and q are my x-intercepts. So that means that the answer for number 1, the x-intercepts, it would be -2 and +4. Remember, since these both have negatives in it, we need to take the opposite sign of the one that we're given. Now the axis of symmetry, remember, is the average of the 2 x-intercepts. So I need to take these 2 x-intercepts, add them together, and since there's 2 of them, we divide by 2. So -2 plus 4, all divided by 2, would give me +1. So the axis of symmetry would be x equals 1. I'd like for you to pause the video and try number 2 on your own, and then turn the video back on to see what you got. Okay, I got the x-intercepts are +2 and +3, so the axis of symmetry right in between 2 and 3 is 2.5, 2.5. In exercises 3 through 6, we're going to graph the quadratic function, and they want us to label the vertex and the axis of symmetry and the x-intercepts. We also need to describe the domain and range of the function. Okay, so these are the 5 things that we need to find. I'm going to start with the x-intercept because this is in intercept form right now, so it's easiest to find the x-intercepts given what we have. So the x-intercepts are found using those 2 numbers there. The x-intercepts would be -5 and -1. The axis of symmetry, remember, is the average of those 2 x-intercepts. So -5 plus a -1, and since there's 2 of them, we divide by 2. That gives us the axis of symmetry as -3. Once I have my axis of symmetry, I can find my vertex because the x number of the vertex is -3. And now we just need to plug in -3 into the original equation to find our y number. So we have -3 plus 5 and -3 plus 1. And that gives us 2 multiplied by -2, which is -4. So that means that my y number, is -4. 4. Okay, now I'm ready to start graphing. I'm going to start with my vertex. -3, -4 is here. My axis of symmetry is x equals -3, so that's going to be, I'm going to put a dotted line right down here. And I know that my x-intercepts are -5 and -1. And then all that remains is just going ahead and drawing a nice curve through those 3 points, and we'll call that done. Oh, not quite done. We need to find the domain and range. So the domain is all real numbers, and the range will be everything above this -4 number. So we have y is greater than or equal to -4. You go ahead and try number 4 on your own and see what you get, and we will turn it back on to see how you do. All right, so I got my vertex as 2, 4. My axis of symmetry is +2, and my x-intercepts are 3 and 1. The domain is all real numbers, and the range is everything below 4. Y is less than or equal to 4. So numbers 5 and 6 are not written in that form that we just learned about, the intercept form. So my first step on number 5 is, and number 6, is I'm going to factor out this quadratic equation. So this would be x plus 2, x minus 2. And now I can go ahead and graph it just like I did numbers 3 and 4. And on number 6, I'm going to do the same thing. We're going to factor it out and then graph it. So I'm going to go ahead and let you try numbers 5 and 6 on your own. Pause the video and then check back and see how you did. All right, for number 5, I got my vertex as 0, -4. My axis of symmetry was the y-axis, x equals 0. My x-intercepts are positive and -2. Domain all real numbers. Range is y is greater than or equal to -4. For number 6, my vertex is -1, -16, so I needed to count by 2's on my y-axis so that I could make it down far enough. My axis of symmetry is x equals -1. My x-intercepts were -5 and +3. And my domain was all real numbers. My range was y greater than or equal to -16. I also went ahead and put these points in here. Since it was written in standard form, I knew, if you remember from a previous lesson, that the y-intercept is -15, so I went ahead and put that in as well. All right, for number 7 and 8, we need to find the zeros of the function. So we need to set the function equal to 0. And then the easiest way to do this is to go ahead and factor it. So I noticed that I can factor out a 6, so I'm going to do that first. And now I notice that this is x times x, this is -1 times 1. So we have 0 is equal to 6, and then x minus 1, x plus 1. So we can ignore, if you remember, we can ignore this 6 here because each piece of this is now equal to 0. Well, 0 equals 6 doesn't really make any sense, but 0 equals x minus 1 does. We can solve for x there, and 0 equals x plus 1, it also works. We can solve for x there. And when we solve for x on both, we get positive and -1. So that means my zeros are positive and -1. On number 8, we're going to do the same thing. Set it equal to 0 and then factor it. And we notice that this is x times x, and this is 5 times 4. If we cross that, that'll be 4x. This is 5x, and that does indeed equal 9x. So 0 equals x plus 5, x minus 4. Plus 4, and so that means that my answers are -5 and -4. So my zeros are -5 and -4. For the last 4 problems, we're going to use the zeros to graph the function. So on number 9, we need to actually factor it like we did on numbers 7 and 8. So let's first do that. Okay, so here I have x minus 5, x plus 2 in the factored form. So that means that my zeros are going to be +5 and -2. My axis of symmetry is halfway in between, so 5 plus a negative 2 divided by 2, which gives us 1.5. So my axis of symmetry is 1.5. My vertex is going to have the axis of symmetry as my x number, and then I just need to plug in the axis of symmetry into my original equation. So I have 1.5 squared minus 3 times 1.5 minus 10, and I got 12.25, sorry, it's negative 12.25 there, and so that is my vertex. Okay, now I'm ready to graph. All right, I set up my graph. I've gone ahead and drawn my zeros in. Now my axis of symmetry, which is at positive 1.5 right there. This graph only goes to 10, so I'm going to have to go a little bit below it in order to get my negative 12.5. So there's negative 10, 11, 12, and a little bit. So there we have it. And I also know my my y-intercept because this is originally written to me in standard form. So I know my y-intercept is negative 10, so I can go ahead and put that in as well. Okay, now I'm ready to go ahead and draw my graph, and we'll call that done. Number 10 is already written in the intercept form for me, so I don't need to factor it. It's already done. So my zeros are negative 3 and positive 1. My axis of symmetry is an average between those two, which is negative 1, so x equals negative 1. So that means my vertex is negative 1, comma, and now I need to plug in negative 1. So we have negative 2 times negative 1 plus 3 and negative 1 minus 1. And that gives me negative 2 times 2 times negative 2, which is 8. So that's going to be 8. All right, I'm ready to go ahead and graph. All right, my zeros are negative 3, positive 1. My axis of symmetry is at negative 1. And I have a vertex up at positive 8, negative 1, comma 8. And there I have it. Okay, let's move on to number 11 and 12. So for number 11 and 12, they're doing something kind of tricky to us. They have x to the power of 3 here, which means it's not going to be a parabola like we have had before. It's actually going to be an S-shaped function. I'm going to solve it just like how I did before. First, I'm going to factor it. I notice that I can factor out, first of all, an x, and then I can factor the second part into x plus 3, x minus 3. So I see that my zeros are 0, positive 3, negative 3. So let's graph just this part first, and then I'll talk to you about what it means. So here I have my graph. I know that I am going to have 3 zeros on this graph. Remember, it's going to be an S shape. So what I know now then is, remember that the vertex is halfway in between the zeros. So that means I have an axis of symmetry here, and I have another one here, because those are in between those two sets of zeros. This axis of symmetry is at negative 1.5, and this axis of symmetry is at positive 1.5. So what that means is that the vertex here will have negative 1.5 comma something, and this vertex will have positive 1.5 comma something. So what remains is that we need to plug in those two x's to find out what our y's are, and that will tell us our vertices. All right, so I'm going to plug in negative 1.5 to the power of 3 minus 9 times negative 1.5. And I'm going to simplify that, and I end up getting 10.125. So that means that we need to go up to 10. My graph is not quite big enough, so I need to count by 2's on my y-axis. And now I can graph negative 1.5 comma 10.125, which is just about there. Now I'm going to plug in positive 1.5 and see what I get. And I end up getting negative 10.125, so that means that this vertex is just under that 10 mark there. All right, so now I'm ready to go ahead and draw my nice curve, and then notice it's an S shape. I know that it's going to be an S shape because, remember, up in our original equation we had a power of 3. So we know it's not going to be a quadratic, it has to be an S shape. Number 12 is also an S shape because we have that power of 3. So my first step is to factor out this problem. My first step is to factor out the 2x, and that leaves us with x squared minus 6x plus 5. And I'm going to factor again, and I get 2x, and then x minus 5. Oops, I'm almost out of room here. X minus 1 is the other piece of that. Okay, so now it means my zeros have to be from this piece here. I know that I have 0 as one of them. From the next one, I know that it's going to be positive 5, and this one is going to be positive 1. All right, so I'm going to go ahead and graph this. Okay, so there I have my zeros. I know that my axis of symmetry is halfway in between the zeros. So I have one of my axis of symmetry at positive 1/2, so 0.5. And I have another axis of symmetry halfway between these two, which is at positive 3. So that means that I need to plug in 0.5 to find that vertex, and I need to plug in 3 to find the second vertex. So we're going to plug those two numbers into our original problem up top. All right, when I plugged in 0.5, I got 2.25. And then when I plugged in 3, I got negative 24. So this means that I'm going to need to count by 5s to make this fit on my graph. So 0.5 comma 2.25 is about here, and 3 comma negative 24 is right about here. So this means that now here is my S-shaped graph that I'm going to have for this graph here. Okay, and that concludes today's lesson on 8.5, which is graphing using the intercept form.